everybody. So today we are going to be talking about, where is it? Calculating molecular weight. Okay, so that's the one we're going to go over today. Just as a review, I've made videos on density, combining ratios, isotopic symbols, periodic table is included in there. The periodic table is basically like how you can use the periodic table to figure out the protons, neutrons, electrons, things like that. Basically just can you use the periodic table, which I have discussed before in a few of the past videos. Average atomic mass we has gone over. Today we're going over calculating molecular weight. We've gone over sig figs, we need to go over balancing equations, stoichiometry, and numbers, moles, mass, and we have gone over accuracy and precision. And I'm also going to add a video in on empirical formula because we did do a practice on that in class today for our review. So I am going to also be going over that because I feel like that's important. So molecular weight should be a fairly quick video here. Molecular weight. And what molecular weight tells us is how much a molecule weighs, right? How much a molecule weighs. And you might be wondering, why do I need to know this? Well, it comes into stoichiometry, it comes into empirical formula, basically anything where you have to do, figure out how much a mole of something weighs is where you're going to have to find out the molecular weight. We're not finding out how much a molecule weighs, we're finding out how much a mole of a molecule weighs. But yeah, so that comes into play. So I'll just give you an example of where it would come into play. So say that you're given that, I don't know, you're asked how many moles in 27 grams of water. I literally just pulled that out of my you-know-where. Periodic. So you do need the periodic table for this because if you hear, I'm also sorry, if you hear banging in the background, my cat is playing with a hair tie. She's actually crazy. So apologies if you have to listen to that. But you do need the periodic table for this, right? So we're looking at dihydrogen monoxide, also known as water, and so there's two hydrogen, and hydrogen weighs 100, or not 100, it weighs 1.0078. I'm just gonna put 1. So if we want to find out how much H2O weighs, we're gonna do 1 gram plus 1 gram because there's 2 waters, so this is gonna account for the water, like the H2 part, plus oxygen. Now I know oxygen off the top of my head is around 16, but oxygen is 15.999. We're just going to write 16 in there. You can write 15.99, but I'm just going to keep that as that. Okay, and then this should equal 18 grams. So that's how many grams are in a mole of, it's grams per mole. Grams in a mole of water, right? So once we have this information, what we can do is we're being told that we have 27 grams, and this goes back to dimensional analysis as well. So a lot of this is all going to come back to dimensional analysis, which I had done a short video on in the past. So we have 27 grams of H2O is what we're given, and we need to find out how many moles there is. We're going to times that by, in 1 mole, there's 18 grams of H2O. Which we just solved for. We just found out that there's 18 grams per mole, right? So you can flip those things, you can do whatever you want, just as long as they stay in that same place. You can do it however, which way you want. Same thing when it comes to like meters per second. Let's say you have to do dimensional analysis and you have to cancel out meters on the bottom, you do seconds per meter, right? It's just, basically moving things around so that you can solve for what you need, right? Because if you remember from the dimensional analysis video, this is the number that we want on top, right? So we want moles. So we'll want moles on the top of the last dimensional analysis part. We want to cancel out the thing that we don't need. We don't need grams H2O. We're just using that so that we can calculate it, right? So I'm going to put this into the calculator, and we are going to get 27 divided by 18. And that gives us, oh wow, that actually kind of works out well, 1.5 moles of H2O. So this is just an application problem just to show you like why we do the molecular weight and where it applies. But just in this video, I'm going to be showing you how to do the molecular weight basically, which I kind of already did there. Okay, so I'm going to show you, and then we're going to do a few practice, and then that will be the end of this video because it's pretty short and simple. All right, so let's say we have ClO3, right? ClO3, let's see, we got 1 chlorine, and we got 3 oxygen. So 1 chlorine will weigh 35.45, we'll say. 35.45 grams per mole. And then we have, that's an L, and we have 3 oxygen at 15.99. Again, you can write 16, you can write 15.99. You're pretty much going to get the same answer. And we got that from the periodic table. Now, we have to add these two things together in order to find the molecular weight. So we do 35.45 grams per mole. Apologies for my dogs. And then we do 3 times, I'll put 16 here, grams per mole. And we are going to get 3 times 16 plus 35.45. And we will get 83.45 grams of ClO3 per mole of ClO3. You don't have to write the ClO3, but that just kind of is like, hey, this is what this is, but you don't have to write that. That's not really important. It's just saying grams of this divided by grams of this, but if you know it's of that, you can just say grams per mole. And let's look it up. Let's see. We'll go here. Molecular weight of ClO3. Okay, it's loading. Okay, so they got 83-ish, and we got 83-ish. So they probably had different numbers in there, and the way they calculated it and everything. But this would be the right answer for this based off of the numbers that we got from our periodic table. Okay, so I'm going to write up, I'll do 2 practice problems in there because this shouldn't be anything that's like too crazy hard. So we'll do NaCl, and then I want you to calculate that, and then we'll do SO4. We'll do 3. We'll do one that has multiple different, trying to think of a compound that has, shouldn't be so hard. Somebody who took Orgo. All right, we'll do C6H12O6. I think this is glucose. I don't take, well, I guess I am taking bio, but like 99% sure that that's glucose. Even if it's not, calculate that thing. All right, so you guys can pause the video now because I will be going through the calculations. Let me mute this so you don't see any. Okay. So sodium has 22.99. So let's write that in there. 22.99 for sodium plus the chlorine, which I think is 35.45. 45 equal to, let's do 22.99 plus 35.45, and we get 58.44 grams per mole. All right, the next thing, the dreaded long one. So C is 12.011. We get that from the periodic table, and there's 6 of them, plus 1, and there's 12 H's. Hydrogen weighs 1 gram per mole, plus 16 grams per mole of 6 oxygen. So we are going to get 12.011 times 6 plus 12 plus, oh god, I don't know what's, let me write this out here so that I know, because I'm not doing this on like any fancy calculator, I'm doing this literally on my phone. 16 times 6 plus 84. Okay, so I got 180 point, I guess you could say 0.7 grams per mole. I'm gonna look that one up just to confirm, but this is always a good thing that you can do when you're practicing, right? Molecular mass of glucose. There we go. Cool. That's just about right there. Cool. So we can move on to the next one. Sulfur. Oh man, I don't have sulfur memorized. Sulfur is 32.0. I think it was 0.66, right? 0.065. All right, 0.65. Plus 4 oxygens at 16. And we are going to get 4 times 16 plus 32.065. We get 96.065 grams per mole. And that would be all of your answers. So that is the end of this video. This was kind of just like a basic overview of it, because it's going to be used in a lot of other calculations, but I hope you enjoyed.